All right. Morning. The topic for today is an arithmetic series. We'll start out with a little game of Are You Smarter Than a 10-Year-Old? Well, maybe not if that 10-year-old is Carl Friedrich Gauss, a famous mathematician in Germany. The story goes like this, that back when he was 10 years old, he was a troublemaker in school, so the teacher said, all right, you're going to stay in from recess until you add up all the numbers from 1 to 100. So within, I don't know how much time, maybe 30 seconds to a minute, he gave the teacher his answer, and he was right. See if you can pause and figure out how to do that. Add up all the numbers from 1 to 100. Well, here's what this little 10-year-old did. He started to write out, well, 1 plus 2 plus 3 plus 4, and then he skipped a bunch of numbers and got all the way to 97 plus 98 plus 99 plus 100. And then he noticed that when you take the first one and the last one and add it up, you get 101. And then you take the second one and the second to last, second to last one right there, you get 101. And then you take the third and the third to last, and you get 101. So you start getting the same sum over and over and over again. And the question is, how many 101s are you going to get? Well, if there's 100 numbers and you're making pairs, that means you're going to have 50 of them. And 50 times 101 is going to be 50. 5,050. There you go. Well, this little pattern works for numbers 1 to 100, but it actually works for any arithmetic series. Arithmetic, what does that word mean? Well, we talked about it a little bit a couple days ago. That just means a pattern that uses addition or subtraction. We talked about a sequence. Now we're not using the word sequence, we're using the word series, and the word series just means take a sum. So an arithmetic sequence goes like this. Goes 2, 5, 8, 11, 14. The pattern is plus, plus. You know, you see a consistent pattern going here of adding 3 every time. That's a sequence. When I put addition signs between it, that's a series. The only difference is when you take your sequence and you add it up. There's a couple formulas for it. We have S sub n. S stands for sum, n for the number of numbers that we're going to add up. It goes like this. If you notice what he did, he took the first term and the last term and he added them up. So we're going to call that A1 plus AN, and that's what those numbers are. So A1 is going to be your first term. AN is going to be your last term. And then if you know what, also see what he did, he took the number of numbers and divided by 2. So he did n divided by 2. And this is your number of terms. Okay, so let's dive right in. This is summation notation. For some reason on my computer, I don't know why, but these numbers are supposed to be underneath, and it doesn't put them there. So let's learn how to read this. This sum right here, this right here means sum. This right here is an explicit formula. An explicit formula where you can plug these numbers in. What you're going to do is count. So the first number you're going to plug is going to be a 1. So if I plug a 1, 3 times 1 is 3, minus 1 is 2. So your first term is 2. Plug a 2, 6 minus 1 is going to be 5. Plug a 3, and you're going to get 8. 9 minus 1 is 8. Plug a 4. 12 minus 1 is 11. This is the sequence that's created. So far it's a sequence. If I go ahead and I put plus signs between them, that creates a series. 2 plus 5 plus 8 plus 11. And it goes on. This is term 1, 2, 3, 4, all the way until I get to the last term. So this says I want you to add up the first 60 terms of that sequence. Well, let's use our little formula. How many terms are there? There's going to be 60. Divided by 2. The first term we can see is 2. The last term we can see is by plugging 60, which would be 3 times 60 is 180 minus 1, 179. So right there we can figure it out. Let's try it on here, and we'll go 30 times 181 and get 5,430. Out of room. 5, 4, 3. Oh. All right. How about you hit pause and see if you can solve the next one. Sorry, that was a little bit off the screen. All right. I'm looking, there's 45 terms. 45 divided by 2. The first term I'm going to get by plugging a 1. The first term, 2 times 1 is 2, plus 1 is 3. The last term you're going to get by plugging a 45. 2 times 45 is 90, plus 1 is going to be 91. So on here, I'm going to go 22.5. That's 45 divided by 2 times 94. And you got it, 2,115. Oh, not dollars. We're getting to dollars in a little bit. 2,115. All right. After that, it's all story problems with a similar idea. I left this box blank here. We'll get to it in just a sec. In training for a marathon, an athlete runs 7,500 meters on the first day, and each day they run 500 more meters than they did the previous day. How far will they have run at the end of the 30-day period? Go ahead, pause it, see if you can figure that out. Got 30 days divided by 2, so 30 terms. Your first term is going to be 7,500 plus your last term. That's what we got to go find out. Well, in order to figure it out, we have to figure out what the 30th term is, and finding that out one step at a time is kind of a pain. But thankfully, we have this guy here from a lesson past equals A1 plus DN minus 1. So if I want to find my 30th term, I can just take my first term, which is 7,500. I can go plus 500, and I want the 30th term, so I can go 30 minus 1, and I can get it. I can go 7,500 plus 500 times 29 makes 22,000. That's not my answer. That's the last term. So now I have my number of terms, which is 30. First term, last term, you go ahead and add it up. So go 15 times. I'll put it in parentheses, 7,500 plus 22. Yep, so you get a total answer of 442,500. So just a quick heads up, don't forget about these old formulas that we used before. All right, you try example 3. See if you can figure that out. All right, a student borrowed $4,000 for college. The loan was repaid like this. How much did they pay over the life of the loan? You might think, oh, and the answer $4,000? Well, unfortunately, that's not how school loans work. You borrow a certain amount of money and end up paying a whole lot more back. So let's see if we can figure this out. So the problem here is we don't know how many payments were made. As I try to figure out my sum, I can say, all right, I don't know how many payments, but I do have the first one, which is 60, and I do have the last one, which is 40.2. So the question is, how do you figure out how many payments were made? Well, the answer is still your explicit formula. You can say, all right, here's the last term I want to find, which is 40.2, or 40.20, is equal to my first term, which is 60, adding my difference, which is a negative 0.2 to n minus 1, or times n minus 1. And now you just have to solve that problem. So you have your difference in here. This n is going to be the number of terms that it takes you to get to 40.2. There's different ways to solve it. There's lots of different ways. What I'm going to do is subtract 60 first. So I'm going to go 40.2 minus 60 and get negative 19.8. It's going to be equal to negative 0.2 times n minus 1. When I see parentheses, I want to distribute, and you can. It's maybe a little bit more work. I'm going to divide instead. Divide by negative 0.2 and get 99. N minus 1, add 1. So that means that there's going to be 100 terms. All right, back here, 100. So we have 50 times the addition of those. 50 times, looks like 100.2. And we should have 5,010. So that's how banks make money, is they give out a loan and then make you pay back more than what they gave you. All right, last one. Can be a little bit, this is without a doubt the trickiest one. If the first term in the sequence is 14 and the next term is 17, and it does tell you that it's an arithmetic sequence, and if the sum of all the terms, oh, it even gives you the sum. It wants to know how many terms are in this sequence. So, all right, you start to fill out your sum formula. It says the sum is 15,631. It doesn't tell you how many terms there are, so you're going to have that over 2. And it tells you 14 plus, but there's actually 2 things missing. And this is when we really get in a pickle, okay? Because you're missing the number of terms, and you're also missing the last term. And we really don't have a way to figure it out. You know, we don't, and if I was going to use my explicit formula, you would need some of those same pieces of information. Well, there's actually another formula that we can create, and it's a slick little trick. Here's how it goes. We're going to go S sub n equals n over 2. Sorry, let me slide that up for you. And then you have a1 plus an. And what we're going to do is we're going to take your explicit formula and we're going to do substitution. So we're going to go an equals a1 plus dn minus 1. And we're going to say an, you go out, and this replacement is going to go in. Okay? So when that happens, what will happen is some of your variables that you need to find are going to go away. You won't need to find the last term anymore. And some other things that you do know, it puts a difference in the equation, and that was not in the equation before. So let's do one simplification step before I'm done. We have n over 2. Here we have a1 plus, and then in here this whole equation is going to go in there again, a1 plus dn minus 1. So the only thing that I'm going to combine is, you see how there's two a1s there? I'm going to call it 2a1. So here's another formula. S sub n equals n over 2. There's an a1 and an a1 for 2a sub 1 plus dn minus 1. So I just took two formulas, crammed them together, and it makes a different formula. It just has slightly different information in it. Okay? You don't need to memorize these. I'll give them to you later in the week, or actually you'll have open note quizzes, so don't even worry about that. All right, so let's use this thing. Let's start filling it out as opposed to the one we were using before. So we have 15,631 is going to be equal to n over 2. I still don't know how many terms there are, but then it changes. It goes 2 times the first term. Okay, so 2 times the first term is going to go 2 times 14. And then after that, it's going to go plus the difference times n minus 1, and we can see the difference is 3 plus the difference, which is 3, and then n minus 1. Make sure I'm showing it to you. Got it. All right, well, it's not the prettiest of equations, but what's nice about it is it's only got one variable, and we know what to do with it. So let's just start to simplify. We got 15,631 equals n over 2. I see a 2 and a 14. That makes 28. Plus distribute for 3n minus 3. Okay, so we're getting somewhere. I see a 28 and a negative 3 making 25. So 15,631 equals n over 2. Then I'll call it 3n plus 25. All right, instead of n over 2, I'm going to start calling that 1/2 n. So dividing by 2, so we can distribute a 1/2 to each one of these. So let's try that. We have 15,631 equals distributing a half. So 1/2 an n. A half times 3 is 1.5. N and n makes n squared. And then half of that would be 12.5n. Okay, we're getting there. Now, many of us have forgotten how to solve this equation. This is actually a quadratic, and you have a quadratic trinomial. I'm going to get this over to the other side, so we're going to go 1.5 n squared plus 12.5 n minus 15631 equals 0. And so you have this. If you have the program from Chief Mings, go ahead and use it right now. If not, then we'll have to use the quadratic formula. We got no choice. So let's try it. We got negative 12.5 plus minus the square root 12.5 squared minus 4 times 1.5 times negative 15631 all over 2 times 1.5. Thankfully, we're in the 21st century when we can use the good old calculator. So let's try it. So we'll go 12.5 squared minus 4 times 1.5 times negative 15631. And we'll square root it. Good. We get negative 12.5. Add that answer. Divide by 2 times 1.5 is going to be 3. And we got 98. So that means that there's going to be 98 terms in that sequence. Tough problem. You could also go this minus that number. You'll find a negative number, and you can't have a negative number of terms in a sequence, so 98 is going to be our answer.